now the stream has been restarted in the correct setting. Okay. So it's now still showing the chat box. Okay, that's good. So is there now audio on the stream? What I can try though is if I put my desktop audio on, right? Is there audio now? Yeah, okay. But I think if I play Twitch as well now. So what I'm curious about, right, is if it's now playing my desktop audio or if it's actually running the plugin, right? So I'm wondering what happens if I put another sound in, right? Because what I think is happening is that it's putting my desktop audio through to the stream. Yeah, so I'm curious about that. I'm just looking for it, right? So do you now hear other music being put through it? Yeah, so I was afraid of that, right? Because ideally I don't want my desktop audio to be shared. Because that could be problematic, right? Hmm. Well, okay, now say I'm looking at a YouTube video, right, for some documentation or anything, right? I don't necessarily want that audio to be shared over, if that makes sense. So I just want the soundtrack to play, right? If that makes sense. Yeah, I think so as well. But I think for today that should be fine. I think I can just oh, yeah. Sorry, yeah. Sorry, yeah, I put it all the way up. Is this better? Or is this too quiet? Because I put it down, like, very, very much. Too quiet, okay. So I'm guessing somewhere around, like, -9-ish, 8.6. Okay, good. And let me at least find, because they're putting classical, let's put something like lo-fi hip-hop beats. Should be a bit more relaxing, maybe, I don't know. I mean, there are a few. There's also sound, please. Nothing. Okay, fine. We'll put classical on. Right. Um. Right. So coming back to what I'm actually trying to do instead of trying to fix audio, is run the Raytracer, right? So it now runs. However, I think my potatoes disappeared into oblivion. Yeah, they disappeared into oblivion because the PVH is broken. I remember. So it was the issue laid with the fact, I think, that the BVH looks to be correct. However, it doesn't seem to apply the transform correctly. Oh, wait a second. So application. Yeah, thank you, man, and thank you for helping me verify the music. It might still be on the VODs, would be kind of a shame because I'm uploading these to YouTube as well. So I think it might still be in the VOD, but we will see from there. And if not, I might have to not upload the stream to YouTube, but that's fine. But well, yeah, it shouldn't be. That's the thing, right? But it also should be playing the soundtrack thing. Well, yeah, no, but I don't think the plugin is working as it should. That's kind of what I'm getting at. But we can see we can see from there. Right. Yeah, I will definitely do. Anyway, I think for now I should be in the clear because this is still music by Twitch and it's playing whatever, right? So it should be good. Right. Oh yeah. So I wanted to check the PVH, right? So while building the PVH, do I think I multiple. Yeah. So I get the. Yeah. So I get the bounds of the element, right? I go over all the models, get the transform. Yeah. Multiply them. Then. Oh, wait a second. Yeah, this is a slight issue. So this would be oh no, it's calling the transform bound function already. Oops. So that's fine. So these bounds are already, because the transform bounds, right? Takes in the transform, then rotates all 8 corners, and then gets the minimum maximum, right? And then it does that for all the models. So that's fine, right? That's good. So then we assign them. That's good. Okay. Now the box size, what's used for something I don't remember. Okay, so to dissolve, the subdivide should be fine. Yeah, because now everything is in world space. Right, we can double check the partition. So transform bound, just with the regular transform. Same here. We get the transform bounds. Okay. Yeah, and here they are already set. Okay, that's good. So then this sorts it one more time after it's being built, and it does this nicely as well. Okay. So now we have the traversing of the scene BVH, right? So we multiply by the inverse to get to local space of the model. Right. Yeah, so this should be okay. Because this definitely goes from... Yeah, this is the formula I've used before my ray tracer. So we just get the ray, we transform it with the inverse, then we get the transformed ray. And then we intersect the transformed ray into the local space bounding volume hierarchy, right? And we pass in transformed ray, and this is infinity, yeah. And then we check if hits, then just do this, right? These things. Okay. So that should all be fine. So what kind of was the issue here? Is that or okay, yeah. So we have this function, right? I'll put it a bit higher actually. So this would hit if it intersects with a leaf node of the binding volume hierarchy, right? So this is now a leaf node, and we can see that it hits this. However, the intersect here, right? So we can see that the ray is transformed here nicely. All these values, if we go to locals, what is it? Ray, transformed ray. There we go. Like, it's transformed and stuff, right? Wait, why can you guys not see the... Interesting. Seems like almost my stream window isn't updating. Oh, yeah, it seems stuck for some reason. Wait, okay, that's interesting. It almost looks like the stream froze. At least Visual Studio did. Right, let me just restart Visual Studio real quick, because I think in the stream it's borked. So it should be an easy fix. Okay, there we go. This now updates again. Perfect. So let's try to debug this again and see what happens. Okay. Come on, stream. Yeah, sorry, this is never going to trigger. This one. Okay, yeah, this triggers. And like I wanted to say, we can see the transformed here are applied fine. Because the origin is... oh, sorry. The origin... Wait a second. This shouldn't be... Oh, oops, transformed ray isn't made. So yeah, these are all like valid values, right? This could be a transform, and that would be fine. There's no really real way to verify if this is done correctly, but I'm using GLM, so the mock here should be okay. But then we go into this intersect, right? This is for the local BVH. I would say traverse, and we simply pass in the array that we have, the box distance, and t that we have here, right? And then we say traverse BVH. And then this, like, basically the same code, but it's slightly different, because this operates on triangles instead of models. But that's fine, right? So we find here that this basically always triggers, right? So this would be, I think, the root node that we hit, but that doesn't really matter. But this always basically misses this intersect. What kind of bounds do we have? Yeah. So this would be -3 to, sure? And 3, yeah. Oh, wait, yeah, sorry. You guys, I keep forgetting that you guys can't see the resharper overlay if I hover over it. So we can see that this, sorry, so current node bounds, right? This goes from -3 till like 3, right? -5 to -2, and for the Z to -6 to 6.5. What could be fine. It's they're somewhere in the scene, right? The or no, they should be at 0. 0. Anyway, doesn't matter that much. So the thing I'm wondering is why we're missing the intersection. Unless, am I doing something weird with the building here? Because I don't think I'm taking care of the transform at all. What is actually would be a good thing. No, I don't, right? I just take the bounds, and they would be like at 0, 0. What's correct? And here there should be the transform ray. So that's peculiar. Redundant. Okay. That's redundant. Sure. I can just dereference that. Sure. Stop. So my question is, how does this miss? Because either something is going wrong with this BVH construction, or something in my moth is going wrong. Both are not very promising, because these are a massive pain to debug. Let me double check if I'm doing this correctly. Bounce, yeah, yeah, yeah. Y, Z. Yeah, no, that should be fine. Infinity, min, max. Okay. Because what I had before, right, is I had min here. And then I did magically render, I think, part of the scene. Yeah. Yeah, see, now we do have a magical part of the scene. Interesting. But I think potatoes can still disappear there on the wrong side of the screen. However, I think they're always... I think I don't seed my random. So they're always going to be at the same position, I think, because it's always the same seed, right, by default. So if we add, instead of like in the application, right? So we have 2, let's add like 10 potatoes. And see what that does. Because I think that would make a quarter of them disappear. Yeah, right. See, we can see the cutoff here. Because obviously there's something wrong with the box. However, this is actually peculiar. So when we go back to this, or what I think is the correct one, we suddenly end up with something that disappears completely, because I don't think we have any potatoes on screen now. Oh no, we do. But it's a different cutout. Okay. Very interesting. Okay. So this is not the min-max, right? Okay. Peculiar. So somebody sent me an interesting link. Work progress in Discord that I'm just gonna check out real quick. So according to here, yeah, you get all the points. So B max, right? So you have B max X, min Y, min Z, then X min, max Y. Yeah. Yeah. So it's basically what I'm doing, and then I'm multiplying it by. Interesting. Wait, so they're unioning the return and okay, that's very interesting. They're doing some really crazy stuff there. But they should be fine as well. So we're just getting the corners, right? These should be all 8 corners. Am I missing a corner? No, because this is index 7, right? So 0, 1, 2, 3, 4, 5, 6, 7. Then we have infinity, 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 minus, 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 right? Now we say out 0 and out 1. So that should give us the proper indexing and sizes for the BVH. However, it clearly doesn't. Right, what we can try is actually, this is something I could do. So in here, right, it considers the cost. But what we could say is we don't split at all because the cost here is really, really high, right? They should never split. They should just have one node. Okay, so it's still cut off. So I think actually I can just do in the subdivide, right? So if splitting costs, yeah. So this would be very high. So let's actually just comment out this and then just put like a huge number here. Or I could just put infinity, but whatever. I just want to see this, right? So this gets triggered immediately, or should. There we go. So we see that we have all the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see 10 potatoes. Okay. This definitely helps. This narrows it down, I think. So if we don't split at all, this should be okay. So if I go back to, say, 1,000 potatoes, right? Do I now get like the weird shape I had before? It's going to struggle a bit with this, right? So now we get the weird shape that we had before. Yeah, and this is going to kill my performance, of course, but that's fine. So if we just have one node, I think the boxes are being calculated correctly, right? Because if it wasn't, it's still making one node for the BVH. Because it's still doing that here, right? So in the subdivide, we can see the following. Sorry. Here, subdivide. So it basically says if the cost is too high, then this is the final node. And in the build, we say that the bounds are the following, right? With the transform. So that means if you have one, the bounds are calculated correctly because we now simply traverse the BVH like before. And we say, oh, yeah, we hit it. Oh, this is a leaf node, right? Return, like, index over all the BVHs. So that means that there would be something wrong with the partitioning. Okay. But that helps tremendously, actually. So if I put this back, then we're back to missing about half the frame. I'm guessing. It's struggling hard with this, holy. It's taking 11 milliseconds to build the BVH. Okay, sure. That's long, though. That's really, really long. It shouldn't struggle this hard. At all. This is interesting. It didn't struggle this part before. Wait, let me just close the application to rerun it. Sometimes Visual Studio is being a bit jank and doesn't really work. At least with the Raytracer I found out that the performance is just really, really bad. We put it back like it was before, and now it's not rendering at all. Really, Visual Studio. Is it being that slow, or is it just... I think it's just struggling really hard. Like, really, really hard. So, I'm actually curious about something. So, in here, in the application in the tick right, we have the weighting here. However, I think we can actually just skip the weight and have the main thread keep running. However, of course, it would kill the performance, right? That's interesting, because what I would imagine if the job system didn't wait, it would oh wait, it's gonna send out more jobs, right? Yeah, ships. Yeah, it's gonna get a bunch of jobs, right? No, that's not the answer. Because I was hoping is to have the UI on a separate thread, so it would update more often, right? However, we might just spawn that async, the UI, and have that render that way, but that's okay. So instead of 1,000 here, let's put this to like 100 and see if Visual Studio wants to cooperate with me and actually render the damn scene. Instead of doing the weird stuff it was doing here. Yeah, okay, right. So this is interesting. We can see that it's a weird mix between having things and not having things. So what I can test here is in the scene BVH, I'm still using binning, but I only, I think, have like 2 axes I split on. So what if I put this to 16, like the other BVH? Because maybe it's complaining because it has too little. It is the binning, then. Interesting. So you're saying with more binning, I get lower performance, but or I get slower build times for the BVH, but my BVH is showing up. Okay. So let's put this to 3. Do I now get a magical scene? Or is it because it's with 2, it's only doing 1 split? No, okay, now we're still missing shapes. Okay. Interesting. So if I put this back to 16, right? What was before. Now this is, I think, the complete shape. I don't think we saw any cutoffs here. No, there's definitely some cutoff, I think. Okay, let's increase this number. Although, something else that has me concerned is the amount of time, because according to this, it's taking 1 millisecond to build, but that seems wrong. It seems to me that it's more like it's taking 1 second to build rather than um, no, okay, it really seems to be taking 1 millisecond because the get elapsed time is 0.001, and the elapsed time in milliseconds is 1 point something, according to the console that you can't see. But that should actually be fine. The construction time is perfectly valid. However, the rendering is incredibly slow. Because the BVH is supposed to speed up performance, not to slow it down. And with 100 potatoes, we shouldn't be getting like sub 1 FPS with the BVH. Like, this performance should be fine. So even if we go back to application here, right? We put this to 2 potatoes. Like, this should run like 30 FPS, no problem. From like it was before. Okay, they're gone again. Okay, so there's definitely something wrong with the BVH. Copy. If I put 10, can I see all 10 of them? I'm just hoping it's not. Because there's something. Right. There's definitely something wrong. Copy. So the scene BVH, right? Yeah, 16 split, so that isn't it. Okay. So let's consider the thing again. Let's compare this to the old BVH. Let's put this. I think we can do the following, right? And then put the scene BVH, right? So now we have two files next to each other. This can help us a little bit with the debugging. Right, so I want the partition part. So the subdivide I'm really not interested in because it's the exact same. Right, so we have partition. No, sorry, partition. There we go. So we can see that we have here the same, costs, same, 3 axes, distance. Yeah, so that's these bounds passed in. Increment is distance. Oh! Oh no, that's fine. Oh, right, my doorbell rang. I need to open that real quick. I'll be right back. Right, sorry, no, this is fine. This should be normal splits because this is the scene BVH. Oops, my bad. I'm being not awake. So it's the difference here goes a bit further, right? So say models begin here instead of triangles because we're now iterating over the models rather than the triangles. So we still say first, yeah, because that's the indexing in the triangle, right? And then we still say first plus count, and then as the predicate we take in the axis, and then we take in 2 shared pointers instead of triangles, because we're now not organizing these triangles, we're organizing the models. That's still the same. Then the difference continues because we have to transform the bounds here. Well, in here we don't. And then we get the center. What if I'm getting the center wrong? That could be it. Because I'm sorting based on the center. If that's going wrong. Okay. I think this is fine. Right, so if I put this on like 0, 20, 30, 40. Yeah, the coordinates determined by x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. And that's your new coordinates. That's exactly what I'm doing. Although instead of dividing by 2, I can multiply by a half. Right. Wait. Yeah, so we first add these, multiply by a half. Right. So this gets me the center of a point. Yeah. So it's just, yeah, point A plus point B. And this is the bound, right? So we want the center of the bounds. Yeah. Then we divide it by half, and then we get the axis. And then we sort based on that. And then we say, this is the exact same, right? And then we say, instead of here, number of splits, we say handle splits. So the current split point is bounds 0, axis, y plus increment, right? Sure. And this part is the exact same. But I think even this is the same. Yeah, however, we changed this a little bit. Okay, no, actually it did change. This is the vertex array. This is all the... we're instead checking the minimum of the vertices, but now we check the minimums of the bounds. So we just transform the bounds again from the model. Then we're getting the actual model. Then model data bounds. And then we transform that, right? And then we have the A bounds. And we say the center is this. And then we'll, yeah, still the same as before. And then if the center dot axis, like in here, is less than, yeah, that's this part, right? If it's less than the current split point, then we do pivot plus plus and then min max on the bounds. But this is in a loop because we have 3 vertices, but now we only have the bounds, right? So it's a bit easier in that aspect. Oh, wait a second. No, this is not correct. Is it? No, it is actually. It is correct because bounce 0 is already the minimum and bounce 1 is the maximum. That's fine. And if not the case, we do the same, but then for no, this, yeah, no, this is correct because it shouldn't be called a bounce, but that's fine. It's basically storing it all in the same value here. Oh, wait a second. No. I think this was wrong. Wait, let me double check. No, because a bounce is the actual transformed one. Sorry. And then, yeah, okay, right. No, this is correct. Sorry. So it gets the transform bounds 0 and 0 and 1 and 1, compares them, minimum, maximum. Right, sure. No, that's correct. Then we do the surface area heuristics, and then we say, if that's the case, do this thing, right? Yeah, no, that should be completely fine. And then we sort once more at the very end to make sure it's in the correct order based on the splits that we provided. So it passes in the info, right? We had the info split access set, right? Yeah, we did. Okay. So I'm going to check pass in model A, model B, and then we transform the bounds. We get the that's interesting. Does this have the same problem? Distort. It does, as a matter of fact. Yeah, no wonder that's not gonna do anything, is it? Levi. It's only gonna get the left nodes. Right. So this might actually fix it. This might actually give us the BVH as it should. I was really hoping that would work, honestly. Right, let me remove this, right, so we get full screen again, so I can actually read what's going on. So then we have the B bounce, but that now actually takes the B node transform. What it didn't do before. And then it does that here as well now. That's fixed. Okay. And let's multiply by 0.5 as well. 0.5f. Because multiplication is faster than division. Well, it's going to make a huge difference, right? But it's just good practice, I think, to take into account. Okay. So this is going to return the A bounce. Yeah, so this is the center. And then we get the X, Y, or Z. And then it's the same here. And then we say if it's less than. And then we sort that based on that. So A is now used twice. And B is now used twice. Okay. And it's the same here. Let me double check that. Yeah, so A is used there. And B is used there. Okay. So that is actually correct. Then A bounce is used 3 times, B bounce is used 3 times, and same here, 3 and 3. Yeah, 1, 2, 3. Okay, that all looks correct to me. So if we run it again, we can still see that we're missing about half of the shapes. Right, we can see these weird cutoffs. So something I have been curious about, did I accidentally... No, I didn't accidentally change this while testing. Okay. So what happens if I put this up to like a really high number? I'm just curious. Not that changing that should make any difference. No, okay, we can still see that's the same, right? Because it's still going to pick roughly the same splitting axis. However, now the art is to find out why this is happening, right? So if we put the cost back up, CMBVH, so we put the, where did I put the cost, right? So we say this instead of the splitting cost here, it's like, or this could be infinity, right? So now the cost is infinite again, and now we should see all potatoes in the scene. Yeah, no, okay, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is correct. Oh, wait a second. Can I actually do what I'm doing? I'm thinking. The way I'm sorting them. Trying to see if that's a problem. I don't... No, it shouldn't be a problem, because I'm sorting based on the center point of the bounce, but there's no rule that bounce can't overlap. That's perfectly fine. I mean, the less they do, the better, obviously, but there's no rule that that can't happen. Because I'm splitting them based on the center points, and then I'm making the bounce from those boxes anyway. So that's okay. Right. So this is fine. The cost is now so high that it doesn't split. So everything is contained in one node. And that's working as expected. So if we split this once more, it's to put this back, we can see that now it will split a few times, and we can see that the cost is yeah, so we're getting this. So I'm guessing there's supposed to be a box here and a box there, but we're missing them, obviously. And we can see a very sharp cutoff here and here as well, what would indicate to me that intersections are going wrong. You know what I could try? So there is the... I'm doing the following, right? Let's minimize the partitioning with the traversal. So I think I'm checking... Yeah, so if I just want to, for now, force navigate all nodes and test if that helps. No, okay. So I can just say if true. So now I will just force actually like going into both nodes and see what that does. Okay, so that means that there's actually something wrong here, right? Because what we're doing, we're saying, okay, so if this is true, then we go in both nodes. And then we get the shape, and I don't want this. Because this would mean that if we intersect both. But I don't think this is ever happening, is it? We could test. I could put breakpoint there. No, so that is never hit, right? But this is, right? So it's either only left shape or right shape. In this case, no. But it's perfectly fine. Then it just returns the left shape. What I suppose is fine. Does this ever get triggered? I could put a breakpoint there. No, so the right shape never gets hit. What is actually peculiar to me? Because if the right shape never gets hit, right, that means that's weird. Because even in the regular BVH, right, we would have this here. So it's reverse, reverse, reverse. Let's minimize some things here. Right. So that would be this function if hit right. Oh, sorry, this clause. And of course that doesn't fire because it's in release. Let's put it to debug. Oops, I minimized my Visual Studio. So debug. So I put a breakpoint here. This should fire. Because it's weird to never hit a right node at all. So this should fire in the regular BVH. Right. Yeah, see, this gets fired. This gets triggered. So I can see left shape is nothing, but right shape is something. So to me, that would indicate the following. Sorry, somebody messaged me. So that would look to me as if the nodes are incorrect, right? So that... Oi. We're triggering here now? Really? Isn't the scene BFH? Okay. Maybe my guess was wrong. So this does get triggered, but it just didn't get triggered in release, I'm guessing? Because release is, being release and stripping my debug information away. Oh yeah, it just never fires in release, okay. That's great. So this does get fired. Interesting, okay. So that brings me to point number 2. No, number 2, sorry, what I was saying. I'm rambling on, sorry. Oh. This is interesting. The normal view breaks. Oh. Right, yeah, no, that breaks. Yeah, obviously. Because I disabled some other stuff. It doesn't set the models correctly. So it's trying to dereference null pointer. That breaks. No problem. Right. Oh, did I do anything weird in here potentially? No, okay. So I just pass in the array as it is, and then I pass in all the models. Right, wait a second. I have an idea. So, when we build the BVH, right, what it does is it moves models around. It sorts them. So what if the scene here, when the scene gets assigned in the Raytracer, it's a copy. instead of copy instead of sorry, I'm thinking a copy instead of the actual thing. So what I could try in here is the following, right? So in application.cpp, in the loop, right, I built the PVH before the first render. But what if I move it after the first render? So that would mean that the first scene, it wouldn't, or the first frame, it wouldn't be built. But that means the second frame would be built. Right, okay, so we do actually get an error. Yeah, because it's never built. Okay. Yeah, that's a slight problem. You know what we could just do? We could just say, when the scene BVH, we could just add a default constructor here, sure. Scene BVH. So that gets constructed, right? No, we actually don't need to. We can just say if there is the regular intersect, and if m dot number, no, what was it? M dot number of nodes is equal to 0. Return null pointer, right? And this is not okay because it's an inside const. What? Oh, sorry, this assignment. Whoops. And this should be by default 0. Yeah, right. So this should return a null pointer if it isn't initialized, which should be okay. But this is okay. No, so it is doing it correctly, right? Because it isn't built before. However, the next frame, it does build the PVH, so that means that we aren't making a weird copy somewhere. What I didn't expect to happen in the first place, right? Because it should be like all shared pointers and stuff. So that luckily didn't happen. So we can remove this code, although it might be good to have around, but I don't like it. Because it would slow, technically, my thing down. Although we could actually put an assert here. Assert m dot number of nodes does not equal 0. Right, because this would this should never be true, because if this is, that means that the BVH isn't initialized. But then we do need to update BVH at the beginning of the frame, right? Okay. So just checking this again to make sure everything is still as before and it doesn't magically crash. Okay. I really hate BVHs because it's really hard to see what's wrong, right? Without actually seeing the BVH. Because the only thing you have is the numbers to go off from. So what we can see here is, like, it's cutting off, but we don't know which nodes are causing this exactly, or why they're causing this. Although what no, that's a really janky code. I'd rather not do that. Yeah, okay. So it's intersecting some nodes, but not others. And it's hard to judge if it's because it's really hard to judge or look down on the where exactly it's going wrong. Hello, Beryl. Welcome to the stream again. Oh, okay. So, wanna know something fun? Apparently, Streamlabs decided your name today should be dark blue, and it's being put like a dark gray background, right? So your name is literally impossible to be read from there, for some reason. Although on just regular Twitch, it's orange, so I can just read that fine. But that's okay. Sorry for the tangent, right? But yeah, we're still trying to fix this mess. Oh, yeah, this mess here. I like as well that you can see two cursors because it's sharing Visual Studio and the application. They're not lined up correctly, so yeah, whatever. Sorry, going off on unimportant things. Right. So the issue that we were having is that the BVH intersects, where it looks like it's built correctly, but it, you know, I actually have an idea. What if we only allow for one split or one subdivision in the scene BVH? I mean, obviously we don't want to do that, but I want to test something. So we say int split counter, and this is equal to 0, right? So if we subdivide here, so they subdivide. So this would mean, yeah, this is successful subdivision. So that would be a split counter plus plus. And then we say in here, so this would run, then subdivide again, but then it would fail. Or if we test it, like these next subdivides would fail. Okay, so then we had the cost thing in the subdivide, right? Or split counter. So this should only split once, because it's going to be 0 for the first node, then it subdivides, and it's going to be 1 for the next nodes. Okay, so now we can see all of them. Good. So say we had more. So I think I have 10 potatoes. Let's say we have 100 potatoes now. I want to see if my left or right node disappears, if that makes sense. Let's put the camera somewhere else. So let's put the camera instead of at that 100. No, sorry, that's okay. So this would be 100 there as well. And this would be, no, so 0. And the camera would be at 100.f and 0. Yeah. So now we're looking at it from the left side. Or right side, doesn't really matter. So I just want a different perspective to see if it's being caught on this axis, right? Because we were looking at a different side before. But these all look fine to me. Beside the fact that my performance is absolutely horrendous with this. I think we have 2 nodes now. Let me just double check. So debug, cbvh, and then after the build, right? Build. And then here a breakpoint. So this should, if I debug this, I should see only 2 nodes. Or 2 nodes that have actual info. So this and nodes. And this is like 201 at watch. And this is oh, okay, no, it only has 1 node. Okay. That is interesting. Right, oh, the subdivision fails because it's... Right, it doesn't subdivide again, okay. So the first split happens, but then apparently it doesn't happen again. Because then these bounds would be different. Right, so we need to increase the split. So let's put that to... you know what's going to happen? It's going to do the left first and then the right. Oh, no, I can't do that either. Ships. You know what I could say is I could put this the subdivide up and say if it's oh wait, sorry, I put the OR wrong. So if split counter, right, sorry, it was if this OR, so it will be true or false, and it's greater than. So that does something really weird. So now this should give me some different results. Ooh, that's taking forever to build now, but that's okay. Oh, there's a debug, right? Never mind. M.nodes, right? Yeah, so now we see three nodes filled in. So this is 0. Okay, wait, this is interesting. So this is 0, and then it's count 100. Okay. So 0, 0, 100. Okay. Then it has 0, 0, 62. And that's 38, right? So this would be 100 in total. Okay, so this would actually mean that we have, I think, 2 subdivisions. No, I think this is actually as it should be. Yeah, this is correct, because we have now the left and right node. Okay, this actually looks as it should. Because we have 100 shapes in total. Okay. This might actually help with debugging. So, can I see anything interesting? Let's first of all put it to release, so we can actually see something. Oh. Release. Ah, okay, that sucks, man. I mean, at least they're putting it together without the GPU. Wait, that's not really gonna help. Do you have an old GPU? Because I don't believe the Ryzen 30. You were getting a Ryzen 3600, right? I don't think it has integrated graphics. But yeah, you might want to buy it somewhere else if they're gonna ship it then, because you do kind of want the GPU. Yeah, I was gonna say I don't think any of the newer Ryzen support have integrated graphics unless you get one specifically with integrated graphics. But this is something interesting you can see, right? It kind of renders half the frame, and then it renders the other half. What's really interesting. This is actually really odd. You can see how like some things are popping in later. Because it should only draw the screen once it's done. It's building immediately the first frame. Like it's popping in some nodes. That's really weird. That's so odd. Let me run this again. I just want to see this again. So we're getting like half. Yeah, we're getting like half of them added like a frame later. What? That's so odd. Because if we go to the application again, right? We load them all in, then we change the scene, we do tick, and then the first thing tick does is build the BVH. And I don't think it has created jobs for rendering yet. Right? Because this holds the main thread busy, and then only here in this loop it creates the jobs. So how does it not have the BVH? How does that work? So if I do the following instead, no, I had this subdivide, right? Subdivide, and remove this OR. Yeah, thank you. Yeah, no, there's definitely progress here. Although the it's having some issues at the moment with the bundle volume hierarchy. if this works, we can re-enable the reflections and stuff. Because what I've been trying to do, right? I could render 1,000 textured potatoes, no problem. However, it was really slow. So I want to build another bounding volume hierarchy to re-enable that functionality to gain the speed even with a high number of objects. But that's having issues. So now I'm just coloring them red so I don't need to store any of the texture info, but it's easy to add later. But yeah, it almost looks like we have the right node here, but not the other node. It looks like we're missing like half of the scene. Because what it kind of looks to me, right, is that this is the actual node, right? And then this would be the left node. Or I think it's actually would technically be the right node. So this we don't hit. So it's cutting things out. And I think since it's not hitting anything, it prefers some pixels, right? Because I think the cutoff is because of that. I think the other node ends here, but this node ends here. So we have some overlap. So it's picking the wrong nodes. Potentially. That would be interesting. So the traverse, right? Let's put this a bit down so I can actually see my code. So the traverse, do we still have the, yeah, we still have the hit if true. We still go into both nodes. Okay. So we just, that also explains why it's so slow. So this should be instead if hit right and hit left. So if hit right, so now we should actually only do that if we hit both. Right, let's see what this is. Yes, it's still the same issue, sure. Okay. So we're not traversing the right at all, it seems like it. So, okay. Yeah. And then else we return left shape. Did I do something weird here? No, this is all the same. All the same, okay. Yeah. No, this is okay as well. Okay. Do we ever hit this though? This function? Or this part? Because this would mean that we got two shapes returned somewhere. I'm kind of curious if that happens. It does, okay. Oh, wait a second. Yeah, no, this is not going to work, is it? Right. So you want to know why this is wrong? This is actually very wrong. This is actually wrong. Okay. I think I might know why. What's happening here? So we need this. We need the transformed ray here. But we need two rays. So this would be yeah, that's a problem. So if we have two shapes returned, it's a right. So what we did here before, we simply got the distance and we intersected them. However, we can't do that anymore because the intersection here is meaningless because this is on the actual shape, but the shape is in local space. So all these values become meaningless, and the intersection will be meaningless as well because the distance isn't saying anything anymore because we would need to transform the ray. So if I do this, right, what happens then? So we just return an arbitrary one, either left or right. Yeah, no, GPU installation is indeed very easy. I mean, I've built my own PCs as well. Um, but yeah, no, I get that. So, right. But even then, if you put in your own GPU, right, you would still have warranty, I would guess, right? Because as long as you don't damage the actual slot for the GPU, like they can't hold you accounted for that. Yeah, so now I'm returning the right shape. I'm kind of curious if I get a different screen. No, it's the exact same. Okay. Oh no, this is a bit different. Because now we can see here some interesting things in this line. Okay. Um, so I'm guessing the hit left fires, right? Yeah, sure. Hit left fires. However, does hit right fire? It does. Okay. Interesting. You know, we can change this actually slightly. So instead of this returning a, yeah, we can actually change this slightly. Yeah, exactly. So let's make a small struct in the header here. So we'd have a struct return info, and the traverse actually returns a return info, and this is triangle, and then we would have a float distance, right? And then we return this. So traverse, traverse, and this would return the return info. That should be fine. Right. Oh, no, I don't think it is. Oh, it would be scene BVH dot return info. Yeah, RT scene BVH. Okay, there we go. Now I fixed the type. So then instead of here just returning this, right, we would get a return and then closest shape and distance to triangle or object. Is it object distance? No, this is the actual one. Okay. Wait. No, it's the object distance. Okay. Yeah, so that is correct. And then we say here, so if, and this wouldn't be this would be RT scene BVH dot return info, and then same here. And I would say triangle, triangle, right? And then we do the same here. And then in here we just simply say return null pointer, comma 0, right? And then we say in the here we say this is return info. Right, and then we return triangle dot triangle. Sure. So now we can say in here, so we don't need this. We do uncomment this. and we say if left shape dot distance. Sorry, so this would be right shape dot distance is greater than or smaller than left shape dot distance. Then we return right shape, else we return right shape. Okay. So this should actually give us the actual distance instead of the weird local distance with the broken intersects. I don't know if this would actually fix anything, but it would be the correct code. Right, so that didn't actually fix it. That's a shame. So, but there's definitely something, because we still have this split, and with these splits here. At least now we should have the actual distance to the shapes. So I think this still fires, right? This is 119, and this is 146, so they should return this, right? Yeah, return right shape. Okay. Yeah. Sure. Oh, wait a second. Hey, this is interesting. I have potentially actually done something very stupid. Yeah, I think I found out what I did wrong. So this is taking a reference. Same here. Yeah, that's bad. So partition takes in a reference. Where else did I watch this up? Right. And the same with the bold BVH. Yeah, this isn't taken in as a reference either. Yeah, that would actually mess up everything. Because it's making copies, right? And then it's editing the copies, and then it's not doing anything with it. There we go. I mean, okay, it isn't fixed. It has some problems, but this is, hey, this is way more of the scene than we had before. This is this is pretty decent. Now it's at least kind of fixed. I mean, I would call this close enough, right? Like, who cares about the few broken potatoes? And we can actually see that the FPS is drastically increased because it's running on debug. So if this runs on release, we should actually see a decent FPS, I think. There we go. See? 25 FPS. And if we now go to the application and change this to 1000, we should see barely a drop in FPS. If the BVH, I mean, the BVH isn't working quite correct, but it's close enough. Okay, that may still kill our FPS, but that's okay. I was hoping that wouldn't kill the FPS. But hey, it's doing something. It's trying at least. I mean, 100 is doable now. It definitely wasn't before. But the shitty performance might actually be from the BVH behaving incorrectly. Right, so let me go back to the scene BVH and just double check. I still have the split counter here. Okay. So did I still check for this in the... I did do this, but I didn't check for that anymore. Okay. Let me see what my construction times are like. Oh, you know what I think is killing my FPS? The actual construction time. It's taking 1 millisecond to build now. Okay. And if I turn this up to 1,000, so I didn't have my console open, so that's why I didn't see it. Now the construction time for 1,000 shapes is... Yeah, it's about 30 milliseconds. Right, no wonder that's killing my FPS. And I think that's happening because in the application, no, sorry, in the scene BVH, yeah, this is 216 instead of 2, what it should be. So it's going to do a lot of calculations when it's too slow, obviously. There we go. So now it dropped massively to 16 milliseconds to build. What still is too long, arguably, but it's a great improvement from before. Okay, so with one split, the building time is very quick, but it isn't great for performance. So 2 should be about fine. Although it's still a long time to build for the BVH, so we have to look in that, because we're going to need a faster approach. Because this is too slow of construction. Because it's already taking 16 milliseconds for our performance. So that means our actual, what you call it? I can't think. Right, so what I could actually do to explain this, right? So I want to move the construction of the BVH out of the while loop. Is that accurate? No, but that will give me a delta time for the rendering. What, is fine. So we can see that the time per frame, so the rendering takes about 300 milliseconds. Okay, the rendering actually takes a long time. That's way longer than it should. Because the rendering shouldn't take that long with the BVH. Because the entire idea is, right, with if the BVH is working correctly, that we go from, instead of 1,000 intersections to, say, 12. So that would mean that it would be as if running 12 potatoes without a BVH. What was running reasonably okay. But this is actually still really, really slow. So what if I increase the splits here, so 16 again, and then, yeah, so increase the splits here. I want to see how long it takes now to render. Yeah, so there isn't a very drastic decrease in rendering time here. It's a bit faster, but nothing very major. It's maybe 20 milliseconds faster. What arguably is a lot, right? But we're also adding 20 milliseconds in build time. So, that isn't really worth it. So that means there's most likely, in my opinion, something wrong with the here. So if we run this again, right, we can see, I think the rendering time jumps to like 330-40 milliseconds. Yeah, 340 roughly. So it's basically the same, but the construction takes twice as long. But, oh yeah, Beryl, but if they're putting your PC together now, does that mean you will be getting it soon? Because I imagine the taking together would be done like in a day and then they would send it to you. Right, so let's check all the headers here now. So this takes in reference, reference, reference. Okay. SD vector, okay. So reference, 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 reference. Okay, it's all taken in by reference. That's good. So now I just need to figure out why my performance is horrible. Oh, the subdivide is complaining. It wasn't complaining before. Let me just rebuild it. Interesting. Huh. So the subdivide, right? So subdivide. Interesting. So it is spouting errors at me, but it's still compiling fine. That's interesting to say the least. The partition. No subdivide conversion from. Why is it trying to investigate it as the? Looks like it's trying to investigate it as. Can I just do assignment here instead? Would you be okay with that, Visual Studio? You would be? Sure. Okay. Yeah, this error has been there for like 5 years now. I don't know why it's there. Huh. No, okay, that's fine. We can go to a flow. That warning can be ignored. Peculiar. But let's put the rendering down to about, what was it? What did I say? Like 100 potatoes before? I guess that was reasoning reasonably, and it was showing the error. Right, I see what you mean. Okay. Right, so here we can see that the rendering time is taking about 30, 40 milliseconds with 100 shapes. But that's almost a linear improvement, or it's almost linear compared to 1,000 shapes, because I was thinking about 330, and that would actually be about 10 times this rendering time. So it almost seems like the BVH isn't doing anything, or very little in that regard. But yeah, I hope for you that they're willing to hold it, I guess, to get your GPU. But yeah, there's still the weird cutoff here. Right. But at least we're way closer than we were before, right? Application, no, sorry, right. CBVH. Hello, Haro. Thank you for the raid, man. How did your stream end? Because I mean, I was watching it till like, what is it, like about an hour ago? Nah, a bit more. I think 1.5 hour. But yeah, thank you for the raid, man. Yeah, it's not actually Vim, it's MSVC. I know I'm a heretic, but yeah, I'm sorry about that. But yeah, I can show you what I've been working on. So we're trying to, well, build a Raytracer, CPU Raytracer. But it was running very slow with a high number of objects, so I was trying to build a bounding volume hierarchy for basically encompassing all the shapes in the scene to find the correct one much quicker. However, it seems that it's not speeding up that much, and there are still issues in here, right? It's kind of hard to see, but there's a cutoff here, straight cutoff, 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 cutoff here as well. So it means that there's something going wrong in my math here with the intersections, I think, because some of the shapes look fine and others don't. So the colors don't look great at the moment, and that's because I currently disabled the texture support and the like color support, right? And reflections and refractions and stuff. Oh, I don't have refractions, sorry. Because I wanted to just test the BVH, and to get reflections working again, I would need to do some stuff. But there was no point if it didn't run right, and it's easier to debug. So it was producing different images before. I think I might be able to show those. If I go back and get Kraken, I think I can do that. Let me see if that works. So I think if I go back to the, I think I can do this. If I stage this. I think I'm not an expert with Git Kraken at all. I'm trying to change my Yeah, also man, have a good dinner. Thank you for the raid as well. Again. I'm trying to get my Git Kraken, my Git client to get my older branch, but it's not liking it at all. I think it's because Visual Studio is open. Let me restart that real quick. No, okay, that's fine. Git Kraken is not liking it at all. Oh, wait. Right, okay. So it seems okay. Oh, okay. I'm doing really bad stuff with Git. I have no clue what I'm doing, it seems. Okay. Unstage. If I have conflicts, right, let me actually share my main screen so you guys can see what I'm doing, right? Main screen, right. So I'm trying to get an older version of Git Kraken up, or older version of Git up. But normally at school, right, we use Perforce instead of Git. So I'm a bit of a Git noob. So I think I can. Oh wait, I think I can just stage this and do stage. I think I can still do this and edit it. Maybe I did something very stupid here, but that's okay. No, we can at least switch. Okay, that's good. Yeah, reload all. I might have given it a horrible name I can't recover from, but that is what it is. So now we should see the old scenes I had. But there we go. Now we can see that the potato is actually rendering. And I don't think I have the branch with reflection right here. But at least we can now see the texturing and stuff working and the colors, right? So that was what I wanted to show. And now I can go back to the actual branch I was trying to work on. Oh, and these can all be Discord changes. Right, and then go back to the main. Okay. Yeah, I think I actually gave my... Oh, I can edit my commit message. Okay, that's perfect. Okay, as long as I can do that, it's fine. Ignore all. Okay. No, I don't think I reloaded it correctly now. Whoops. Sorry, I'm a bit messing around with Visual Studio as I have no clue what I'm doing. Clearly. Right. So now we should go back to the BVH. That should be fine. Or we should go back. Yeah, no, there we go. This is perfect. So we're back to the not working BVH. Okay. So now I was trying to figure out why I was having these cutoffs, right? Because those shouldn't be happening. Because what should happen is that they go both left and right nodes and basically check them. So we can see cutoffs basically everywhere because they should be rounded. But at least I'm getting now the entire scene compared to before I was only getting like half the scene. So now we're getting like 90%, what I think is a great improvement. So what we can do, even if we do hit left or hit right for now, just brute force all the nodes and see what happens there. Because if we now get all the scenes, we know that there is something weird happening. Okay, we don't. It's not saying if we hit left or right, then go in both the nodes. But we don't. But that doesn't change anything. Because basically the algorithm is quite simple for traversal, right? If it's a leaf node, then do intersections and cool stuff. If it's a branch node, check if we hit the left and right, and then only go on the left or write nodes if we only hit one, and if we hit both, we need to obviously search both. And then if it returns only one shape, we can just return that one. If it returns two, we actually have to check which one was closer. So that is quite simple in theory. Oh, I think this is why it's messing it up. I think we were just simply returning the wrong shape. No, okay, that would have been lovely. Because we're supposed to hit right. So if the right shape is closer than the left shape, return right, and else left shape. But it was right shape before. But apparently that didn't fix the issue, as we could see. So this should be fine, and then left shape. Okay. And by the way, this is a recursive function as well, right? So we call traverse BVH again for every node that we traverse through. It's the same with building the BVH, it's recursive as well. I mean, the entire Raytracer is pretty much recursive and multi-threaded. But what I find extremely odd is the cutoffs. Because you can especially see, like here, right, a tiny cutoff. And same, or was it here? So one thing I could do, I could change my camera perspective, and that might give me a slightly better perspective on this. So let's put the camera on the Z-axis. Yeah, and then the... Oh, sorry, it's the light. That's fine. 0.f and 100. The ray tracer in actually moving positions is kinda basic at the moment. It's just hard-coded all. Oh, we can see it much better here. Okay. So we can clearly see that there are things wrong here, right? And this is an extra weight potato. You might be asking why I'm using potatoes as a reference, and I actually have no clue. I think one of my viewers once was like, hey, you render a potato? I was like, sure, I can render a potato. Now we're ending up with potatoes as references. Although, I mean, we can change it technically. We can change it to whatever we want. So I could change it to the... I think the model is called this. And this should render fine as well. And I should end up with 100 cars. No, okay. Oh, whoops. The obj name is wrong. It didn't load it incorrectly. Let me get that name real quick. Oh yeah, I misspelled it. Okay, that's fine. So it's this name. And it's going to crash, obviously, once it does load an obj, because it's trying to render something that doesn't exist. Right, there we go. So now we can see that we have 100 cars, like, flying around, right? This scene actually looks alright. Weirdly, it's hard. It's really hard to say without colors and shading. You know what I think I'm gonna do? I'm gonna re-add the shading support, so we can actually get information about this. So we get the... How did I... Oh yeah, right. I need to know the model that we intersect, right? So we can actually do that in here. Sorry, not application, in the scene BVH. What we can put in here is we can have a model reference, right? And this would be a reference, and this would be a model. And then in here we can can I say... I don't think I can say this is because I don't think I can say this is null pointer. STD make shared model. Sure. Just by default make that a shared pointer, and I don't care what's in it because we're not using it. Although I do think I need to include the model to actually do that, right? because it doesn't know about the type that it's trying to construct. Binding in, right. I could do this. Oh, and this needs to be on the bottom, obviously, because it's default construction. We're passing in 2 arguments here, but yeah, sure. Yeah, it's missing the. Yeah, sure, it's missing things here, but it's okay. And then in here we say yeah, we have the model reference, and that is models.index. Yeah, Beryl, see you, man. Thank you for joining the stream. Right. So that actually returns the model here. And then in this PVH, I actually want to return not just the RT triangle, I want to return... I could just return the hid info here, actually. The return info. Because that contains some information that is actually useful to me. So I could just say return, and the intersect, return this. And then in the intersect, we say this, RT return info. And then we say return triangle. Right. And then we can go back to the Raytracer, and then we would need to right, so this wouldn't be the hit triangle. This would, we need another line. What would be RT hit info? What do they call it? Intersect. Oh, return info. And it's equal to this. So this is return return info, right? And that's equal to that. And then we can say this is equal to return info dot. Was this the boolean or was this the, no, it was the triangle, right? And then we can say if this, then no, we still need the local hits, but that's okay. We can calculate that. And then we, yeah, so we would get the return info. So first, we need to calculate the point. So glm vec3. I don't know. Thank you for the follow, man. So this would be hit point, right? Hit points. That's equal to return info dot distance times ray dot direction plus ray dot origin. Right, and this would actually be our hit point. That would be the roll intersect, and this would be then return info. Said Wu, thank you for the follow, man. So this would be return info model dot transform dot get inverse, and that would be multiplied by the glm vec4 local hits comma 1.f, and this would be then the position, the hit point that we just calculated, and then we move that into local space, and then we say as well hit triangle would be return info dot triangle, and that would be return info dot model instead. And same for here, right? So now we have this, and then this is the return info dot distance. So now we have all the hit information back again. So I think that is everything we would need to actually re-enable the shading. Did I need text color? Yeah, no, that should be commented out. Okay. So I think now we have the shading back. Fingers crossed. Never mind. Oh, okay. This is a minor minor issue, because it said the it thought it was in a different namespace. Okay, yeah. Oh, whoops. Yeah, we need to remove the namespace here. I think that might be still fueling around. Interesting. Why is this the deleted function? Huh. Was this building fine? No, it failed. Okay. So non-const. I think I could just have this being uninitialized. I think that's okay. Instead of initializing it. Yeah, I know it's uninitialized. STD, make shared, RT. Right, sure. I don't really care. I don't really care what's in there. I just need to assign it later. So this can just be an empty pointer. What the? Oh, wait, this is no pointer 0. No, I should be able to just set this to a null pointer, right? Oh, wait, this is... Right. It shouldn't be a sharp pointer reference, it should be a sharp pointer. Right. And we can set that to be equal to null pointer. Yeah, right, because we can't do that with references. I'm actually being stupid. So we do that, then we say this, 0, null pointer. Okay, I'm gonna try this. So 53 GF, Bolt, thank you for the follow. I think I pronounced it decently there. And we don't need these values either. Right. I think now it should compile. There we go, now it succeeded. So fingers crossed again, now we should see the shading. Close enough. The model didn't get set. Okay. So we intersected. So the hit triangle is set, but the hit model isn't set. Okay. So scene BVH. So that would be done here. So, oh, right. Oh, and this would be... did I call this weird? Local variable model is assigned but never accessed. Wait, what? Oh, wait, this... Yeah, right, there we go. No wonder it didn't find it. It was a local variable, right? Yeah, okay, sure. So now it should actually set the model. I'm being an idiot with assignments. Okay, there we go. That's at least textured. And I think the only issue is that the light is in the very center of the scene, causing complete the scene to be completely overlit. But we can fix that very simply by saying this is at 100, and then this will have an intensity of 1000 as well. I think now we have the shaded cars again. And this is going to help us massively with debugging, right? Okay. Yeah, there we go. We now can actually see the cars and their shading. And now we can see that there's actually issues again, right? We can see here this wheel being cut off. Same with, I think, I saw another car. So this car, there were a few cars, I think. But this is much better. And now we can do other cool stuff, like re-enabling... Oh, on my stream, you can't see all the options, right? I can't really drag out the UI because it's running at 5 FPS, but anyway, if I press this button, I can enable the normal view, which shows me all the normals. So that's pretty cool. And I can do the depth view as well, so I can kind of see how deep objects are. But this is, I don't really like this feature too much. It's too hard to really see depth because the bluer it is, the closer it is. But it's really hard to see. But the normal view is actually really useful, because it's going to help you spot like weird texturing issues. Like if the normals are all over the place, it's clearly wrong. The normals normally should be like basically on the same direction, right? And we can clearly see that that is correct. But yeah, no, this is very, very helpful. So I think with the potatoes now, it's going to be a bit easier to see as well. So I just want to check that textures are also working fine. So this would be potato, potato.obj. Right, and this should give us a 100 potatoes with potato textures. Right, there we go. And we can see that this is clearly working as it should. And we can now see the textures here as well, what I think is really nice. Yeah, sorry, I needed 3 seconds to catch my brain up. To catch up with my brain. So let's switch back to the cars, because I like those a bit better, actually. I think it's about time we mature from potatoes to cars. And try to figure out what's actually wrong here. So let's go over the intersections, right? Like talk over the code and see what it does. That might help spot the issue. So the code roughly in the Raytracer, right? So it goes, hey, I want return info, and I'm going to intersect the scene BVH, right? So we go in there, we intersect, and it says, well, sure, you can do that. We will traverse the BVH for you. And it passes in node 0, what would be the root node, right? Then we traverse. And then the first thing we do is we check, do we hit this node, yes or no? Because if we hit the node, if we don't hit the node, right, why do all complicated maths? We just leave. Next, we say, okay, well, is this the final node, right? So a bounding volume hierarchy has a root node, then that has 2 children, that left child has 2 children, and it keeps going like that, right? So at one point, the tree has to end, and we check that here. We're saying, oh, is the count 0? So if it's not 0, that means this is a final node. Then we simply loop over all the models, and we get the closest one. So we transform the ray with the inverse to get the ray to the local space of the car. So why do we need this? Well, every car has a transform, and the scene BVH is built in world space, while the BVH for the cars are built in local space. Why? Because there's only one BVH for the car, right? This is a high quality bounding volume hierarchy that's been pre-calculated and is saved on my computer and then loaded in every time. But the scene BVH is rebuilt every frame because it would allow for moving objects, right? But this is a lower quality BVH, but that's fine because we just want to speed up possibilities. So we need to transform it back to local to do the actual intersection on the high quality BVH. Then we say, okay, we hit, and this is the triangle that we hit, and we say, oh, do we hit something? Okay, cool. Then I need to put this local hit back to, so I need to calculate the local hit. What's the distance times origin and times, direction times the distance plus the origin. Then we and then we have the vector 4 local hit, and then we transform that back to the world position, right? And that will be actually, and then we can actually calculate the real distance to the object, and then we simply say, I want the closest one out of these, and now we save these, and then we return that. So this basically gets, say we have 3 models in a node, it would return the actual closest triangle here. Say it's not a leaf node, we would go to the else statement. So we say distance left, distance right. We have left shape, right shape. So this would be rather be left node, right node. And then we say of a boolean hit left, hit right. And the right node is simply accessed by the current nodes plus 1, because that's how we set it up, right? So the root node has a left node, and then right is always plus 1. Then we check if we hit those, and then if we hit both of them, well, we're going to have to check both of them. I think there's a possibility to skip nodes here as well, but I've had issues with getting that working exactly, so we're just saying go both. If you only hit the left, well, obviously we can completely disregard the right. And it's the same for the opposite, right? If we hit the right, then we don't want to go on the left. Then they should actually be on a new line. if we hit nothing on the left, but we do hit something on the right, we simply say, oh, you just return the thing on the right. If we hit on the left and the right, we need to check which one of those was closer and actually return that value. So if the right distance is closer than the left distance, return right, else return left, and then we finally have a left. But basically the opposite of this, right? Because if this didn't happen and this didn't happen, it's the left shape that we care about. And that returns, and that it basically keeps going up the stack in this process till it finally is done here, and then it simply returns that information, right? So now why do I still have cars? So what would make sense to me the most is that we're missing things. So what I could test though is in here we say only if you hit left and right, but if I do or, so if you hit either of them, just go in both anyway. Because this would eliminate the possibility that there's something weird with overlap, right? But we can clearly see that doesn't change anything. So that would indicate to me that there's most likely something wrong with the bounding, the volumes themselves being not completely accurate. Because we can see it here clearly, right? And usually the very sharp cutoffs indicate that there is something wrong with the either the traversal algorithm or the calculation of the volumes, because it's either a yes or a no for the hit, right? So if it's a straight line, everything here would hit, everything there would miss, so you get a straight cutoff point. What would indicate like that would be this line, and it's a straight line as well here, right? But I can I can only really see one car, I think, that does this. However, we can change your camera perspective again, and that might help with the cars a bit. So put this to 100 and 0 to left. And then with the light as well, we put this at 100, so we have some light towards us instead of from the side, so we can actually see things. All right, okay, yeah, we can clearly see here is a cutoff. Yeah, this is very clearly cut off, right? I am curious about one thing. Does it maybe clip with the camera? Because it only seems the very closest one is. So if I move the camera back, say, like to... Sorry, that's a light. The camera to, like, 200. Just to make sure it's much, much farther back, right? Do we still get the weird clipping? This is really hard to see, but I think we are here. I mean, we can put it instead of we can put it to like 150, and that will give us a good middle ground here. So that should still allow me to actually see what's going on. Yeah, we can still clearly see the cutoff here. But what is odd to me? Yeah, you see 3D now. Yeah. So I while you were eating, I fixed the shading, so it actually now shades and textures. So we can see that we have texture support as well if I change the model, because the car doesn't have a texture, or at least I didn't get the texture. Subtitle does have a texture, and we can see that that is working as well. Render and render. However, what you can see here, right, there is this weird cutoff along a few models. I think here as well, where you can clearly see that there's something still going wrong. However, I'm trying to figure out what exactly is going wrong there while you were eating. But we're very, very nearly there, I think, because we came from literally having a barely working bounding volume hierarchy to one that kind of works. Yeah, these cutoffs here are very weird to me. Like, these are extremely straight. So one of the things that could be happening is I have this helper function, right, that calculates the vertices and gets the minimum and maximum with the rotation. However, if I'm skipping one, that could cause the cutoffs, because it might do it wrong. But I think I have all 8 corners correctly. I hate this code. Yeah, no, that does really seem correct, because we're getting, like, this is all the same X-plane, right? This is all the same X-plane. Then we're getting the 2 nodes on the same set and same... Wait a second. No, this is wrong. These are literally the same... Yeah, they're the exact same. Oops. Because these are on different vertexes, Levy. Right, okay, yeah. We're getting the wrong vertexes, right? So we'd have 4 positions with the same x value, right? But we would have 2, right? So we have 2 at the bottom y, but then the z's would be different. Then we have 2 on the top y, but the z's would be different as well. Right, same here. So we'd have the same here, but then we would have a different z. Oh, sorry. No, wait. The z here is, yeah, 0, 0. So these are still all identical, right? This would be, let me think about this. Yeah, let's put this all to 0, just to think about it real quick. So these would be on the different x-plane, but then we would have 1 on the y, 1 on the different z. So we know it would, yeah, we would have 2 on the same y, but different z's, yeah. And then we would have 2 on the different y's, but on different z's as well. So I think that's actually gives me correctly all 8 corners. And there we go. The cutoff is now magically gone. So what did my dumb ass decide to do? Skipping half the vertices. So what happens, right? Let me draw this in Paint. To explain this. Right, Paint. So imagine we have a box like this, right? And we have these 2 vertices. We have this one and this one. Let me get a bit bigger brush. So we have these 2 vertices. Then the resulting bounding box, right, would be this, right? Like around these vertices. I mean, obviously they would be exactly on the vertices, but that's fine. For illustration purposes, is enough. But now imagine the box is rotated. Can I rotate in Paint? No, okay, I can't. So imagine the box is now rotated like this, right? So it's been rotated. So now these same vertices are this and this vertex. And the resulting bounding box for that would be this, right? So it would get smaller. So you would compensate that by transforming all corners, and it would be 8 in 3D, right? But only 4 in 2D. And then checking the minimum maximum. However, what I was doing was basically, I was like checking 3 out of 4, for example, right? So it wouldn't quite give me the correct box, if that makes sense. So I was checking only 4 out of 8 of the correct vertices. So now we're checking all of them, and it is actually giving us the correct bounding volume. So now we can see that this is working. So if we change this back to the cars as well, yeah. No, wrong file. Here. So if we change this back to the cars, we should see that this doesn't have issues anymore either. I'm actually really happy I solved this because I was stuck on this forever. Yeah, now we can see this wheel is nice. I don't see any cut-off cars. And this is running at an entirely glorious 5 FPS. Because the rendering is taking forever. The BVH construction, on the other hand, is actually taking very little time. So the BVH construction is taking about 1 millisecond for 100 objects, what is okay. But what happens if we put this up to 1,000? Because if the BVH is doing its job correctly, this should have very little impact. But I don't think it quite is. Yeah, so the time per frame is jumping up massively. And the construction time jumped up to about 16 milliseconds. So that isn't great. That's a long time per frame. But I mean, we are rendering a ridiculous amount of triangles. So let me actually see, like, what kind of values we're getting. Yeah. So each car has, I can tell you in 3 seconds how many vertices. Locals, this, test scene. Oh, sorry, model data. Come on. No, I have the model, right? Model, sorry, wrong pointer. Model data. It has a whopping 93k triangles. So, I mean, we could put this in a calculator. So, 93,387 times 1,000. So that means that we're rendering 70 million short of a billion. So we're rendering a grand total of this many, was it vertices? Or triangles. So we're running about 900 million triangles. Or 933,870 to be exact. You know, maybe I shouldn't be complaining about the performance for that. I think that's actually pretty reasonable. What is the vertex budget of, like, how many vertices can Unity handle? So Unity can handle bits per model. I'm just curious how many polygons is too much. So according to this, it would handle about anything between 5,000 to 6,000 triangles is reasonable. But 6,000 triangles doesn't seem like a lot for models. AAA games, right? Although actually that might actually be reasonable because you can use techniques like different maps, right, to bake a low detail model into a high one, or at least you can fake that. So I might actually be okay with this kind of performance. I think this is actually perfectly acceptable. Maybe. It's just really hard to see if it's working correctly. I mean, the performance difference for sure is insane. So this was running, what did I say, about half a second a frame, about 270 milliseconds, right? So I want to show you guys something else. So we have, let me actually open my previous Raytracer. Right, this one. Sorry, I'm just looking for the file. Right. Yeah, whatever. That's fine. And then release. So this is my old Raytracer I made. And it has really horrible UI. I don't know if you can read the UI on stream. I hope so. But this scene in particular is running about 12 FPS. And what do we have model-wise, right? We have 1, 2, 3 cubes, and those might actually be... No, I think those are actually models. But I think the cube here, the spheres, are all like actual primitives, right? They're not models. They're like math primitives. So even like the lows, like the simple scenes, right, are running in 6 FPS, like a bit less, and these are like a handful of triangles. Uh, Same with this one. Like this scene is, and these might actually be. I think these are cube primitives, not even models. So this has like I think like a few thousand boxes. So even then, if we're considering that number, that would be, if it's a box, that would be 8 vertices times 10,000. Oh, sorry, that's division. So 8 times 10, okay, that would be 80,000 triangles only. Right, so let me close this. Let me check the scene here, right? So this would be, it's 5,000 shapes actually. 5,000. That's nothing. This would be 5,000 triangles. And this is the same car, right, that you saw before. And this is running at 7 FPS. And there are the plain primitive in the car. So we can actually benchmark this against the other one. That's actually reasonable. Because I think we roughly have the same features set in. Like, we have the shading, we have the stuff like that, right? So if we go back to this Raytracer, and then say I want only, I want 5 cars. Actually, I think my food is ready out of the oven. I need to grab my food real quick. 1 second. Right, I'm back. Sorry. Right. So this is running at 100 FPS. What's okay, way better. But we're not giving it a complete fair comparison because this camera is way further away, right? So this should be more like 20.f, and then the car should be a bit spaced together more. Because we can't really compare it if the camera is really far away. Because air pixels are really cheap to calculate. Oh, this isn't quite working. So, so let's put this to like 35. Yeah, air pixels are really cheap. Car pixels are expensive. Yeah, 1, 2, 3, 4. Okay, I think we're still missing a car, but yeah, this is running in 20 FPS, right? This is like actually usable. I mean, I wouldn't say it's like perfect real time, right? But this is about a million times better than before. And normal view, like this, I call this a turbo button, but it really does. So I'm curious about something. So if I say the cars model dot material dot reflective index equals to this, right? Because now the cars become reflective. Okay, that looks really funky. So they're reflecting the background color, right? What caused them to be green. But they don't really reflect the other cars. So let's add a few more. Yeah, we can see it working here. We can clearly see that there are reflections in the cars of other cars. That means that's working as well, as it should. And you can see that reflections do obviously take quite a bit hit on the performance, because for every reflection means an extra recursion on the entire rendering loop. So that means with reflection, each pixel becomes twice as expensive. If we had limited up to 1, but it can become 3 or 4 times more expensive if we have greater depths, like recursion depths. Because if it reflects, like say it reflects here, right, on this car, then reflects again on this car and then back, it would be 4 reflections, 4 recursion loops. But reflections are reasonably expensive. The real expense comes from, but a real expense comes from refractions. Refractions kill your performance like massively. But I think we could actually get refractions in. I think we would have everything actually needed. Because all we're missing is the moths for reflections. Because the recursion's already there, the material's there, it supports it. So the only thing I would need is the moth. What I could do is my old Raytracer has it, right? So we can simply yoink that and take that moth. Right. So taking this function, Raytracer, and then we have a... We can actually get rid of this. We don't need this anymore. This is the old intersection code, basically. We have this function, the calculate Fresnel. Constant, yeah, RT array, and this is a glm vec3 normal. And the only thing I'm not sure about is, we need we can just do passive float refraction. Refraction index. Right, and then we can just put this in here as a private function. So this would be float. So what is this Fresnel, right? This Fresnel is basically a value of how much gets reflected and how much gets refracted. What is quite important. Because maybe you've ever seen it in water. If the angle between the refraction and surface is a certain size or certain angle, it basically completely reflects instead of refracts. So there's some weird math stuff coming in there. So this would be glm dot. This would be ray direction and normal. Right, and then closest shape. This would be refraction index. This would be STD swap. Yeah. Yeah, sure, that's all exactly fine. And then from the other ray tracer, we're gonna need another function, and that is the refraction part. And then, this needs to come off, of course. And this would be, instead of color, it would be a glm vec3, and it would be, of course, here a glm vec3 as well. I think we can actually just pass in hid info, to be fair, instead of all this. Yeah. So we can just pass in hid info reference. Right. and then generate implementation, and then the implementation is going to come from my other thing, and bam, there we go. So that's obviously oh, well, a lot of errors, but we can fix most of them very easily. So this would be glm vec3, same here, and this would be info dot material dot refractive index. Was it refractive or reflective? I forgot to check. It's the refraction. Okay. So then we say Fresnel. Oh, although what do I pass in as? Right. So let me double check my rendering thing. So for this we do reflection color is calculate refraction. Okay. And then yeah, where do we use Fresnel? We don't use it anywhere else. What? Why do we pass that in at all then? Okay, very interesting. So it would be info dot hit triangle dot get normal. Oh no, sorry, get normal. Oh wait. Oh yeah, get you just need the normal and the refraction index. Okay, and this would be info dot material dot refractive index. Okay, and this would be float Fresnel, right? And then glm dot is what was ray dot direction and normal. So what's the normal, right? I forgot already. Calculate Fresnel. No, calculate refraction. Yeah, it was the normal. Okay. So it was info dot hit triangle dot get normal. Okay. And then this is a glm vec3, and this would be yeah, this is glm refract, and this would be, I think this takes in the original. Right, let me double check. So glm refract. So this takes in the, no, sorry, refract. Right, the normal, the I. Okay. So this is the. So take in hit info. Info dot hit triangle dot get normal. Then the I is ray dot direction, and then this is Fresnel. Is it? Yeah, this is Fresnel. And then we say transmission ray equals glm normalize transmission ray. Then we say info dot intersection world intersects, and then we need the normal vector. What's this? So this would be info dot world intersects plus this, and then we have trace, and then we don't pass in the current depth, so this would be a int depth. No, I don't want to do that. Visual Studio. And then I say depth plus 1. And I say glm vec3, glm vec3. Oh, I think this is just the This is reflection, okay. So this would be ray dot direction, and then the normal vector again. And then that would be a GLM normalize. I think these might already be normalized, but for the sake of it, I'm just gonna normalize them again. So this would be info.world intersects minus the normal. Info.world intersects, right. And this would be a trace as well. Okay. And then return this times this times this. Okay. So then we don't need to call reflect again. What would be this part? Yeah. This would be refract. No, how did they call this function? Oh, calculate refraction. Right. And sticks in ray and hit info. Right, and I think this should still be fine. Sticks in the ray, yeah. But this returns a color, right? Oh, right, this isn't a const function. Whoops. Right, sorry. And then this should be const as well, and then this one should be const. Yeah, obviously that's not going to work. Okay. Did I make these cars reflective? So let's do the refractive index. No, I think we can do both. And then we say refractive. Yeah, so now we should see refractions, hopefully, if I did everything well. Well, there's a high chance of it not being. No, that's not quite correct. Oh, yeah, we're calling it with the wrong numbers. Oh, no, that doesn't matter. Okay. So, why isn't this working? Let's see. Debug. Because I did do some weird stuff in here in my last Raytracer. Like with the transmission ray and stuff. Oh, and the assert is obviously going to complain. Right, let's check. Getting build errors now? Okay. Oh, I think I did something weird while deleting. Oh, yeah, I did. Oops. Right, I deleted some of the bracket I should have deleted. Mm-hmm. Yeah, so Fresnel, that means that we're basically reflecting everything here. So yeah, we say, okay, well, we get the transmission ray. So this would be the refracted ray, yeah. And we say, well, this transmission ray is now this. Actually, why do we have this weird ass scope in here? We don't need this at all. Right. So let's put a breakpoint again here. Wait, so outside is false. That's weird. Because the outside shouldn't be false. Huh. Because it should be inside, right? Oh. Maybe I did that the wrong way around. Scratch a pixel refraction. Right. So refraction. Getting strength to get them off out, right? So that's less than 0, right? So if that's the ray direction and normal, right? Yeah. Sure. Yeah, that should be okay. Let me check if. Yeah. Let me see if I can get the complete. Right. So the Fresnel should be the exact same as I have here, I think. Yeah. EN, yeah. 1, your, yeah, sure. Then if this is greater than 0, swap, yeah. Then this value is equal to a tide, yeah. Square root f max 1.f minus cosine, yeah. I'm just checking my code against the online source that I've been using. So sin t, if that's greater or equal than 1, then this is 1, yeah. And else, so this is square root f max 0, 1 minus, yeah. Okay, that's correct. No, this is correct. This the actual Fresnel part. Okay. Right. So the outside, right, is the ray direction dot normal. Okay, yeah, sure. And we're checking if that's sure. Then if this is less than, yeah, transmission ray is refract. Yeah. So minus bias plus bias, yeah. Okay, that's correct as well. And then we say trace, right? Yeah, we cast a ray, and we cast a ray from the refractive ray, and that plus 1. Yeah, that's perfectly fine. Then the reflection is very similar as well. We say GLM reflect, set ray direction normal, outside, blah, 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 this stuff. Okay. So we do minus the normal here and times a small number to basically offset it hitting itself, right? What's causing some issues, so we need to offset it slightly to prevent that. What's up, Iggy? Thank you for the follow, man. Good to see you in this stream as well. Right, so, sorry. And then the final color is the reflective color that we got times the Fresnel times the refractive color 1 minus Fresnel. Oh, wait a second. The refractive color is 1 minus Fresnel. So it would mean that there's almost nothing being refracted. Okay. So let's see if there is a if Fresnel is less than 0.3, sure. 0.3f, then I want to do a printf and then slash n, right? I just want to know if there's ever a significant portion of daylight being refracted instead of reflected. Yes, it is, right? So we can now see that Fresnel, there's a very big part being refracted. Oh, but it's 0. Okay. So it seems that there's almost no refraction, or this trace resulted into nothing. Okay. I am curious about something. What happens if I... No, the reflections were fine, so that's not it either. And let's do and refraction refraction color dot x does not equal 0 dot f. So stop, of course, because what I'm curious about if the x is ever like non-zero as well. Okay. Yeah, so we have a color here now. Oh, could it be? Right. I think what's happening is it's yeah, okay. So I think we should multiply with Fresnel because it's trying to do shading, I believe. What obviously shouldn't happen. All right, so let me check this, right? So we have the trace. Oh yeah, sorry, constraint, yeah. All right, so let me open the this on stream as well, so you guys can see light capture, right? And let me zoom in a bit, right? So this is the Scratch a Pixel resource. So we say retrace, right? Blah 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 blah. Okay, case right. So in case it's reflection and refraction, right? We say refraction color is 0 and this is right. So then we get KR. What they do here, right? But I don't think they apply shading here. So if it's diffuse, I don't think they apply diffuse here. Do they? So I'm wondering, I'm trying to look for an enum here. That, no. Which are, okay, yeah, oh, there we go, that's the enum. So it's just a static one, right? So it's either diffuse or it is reflective. Okay, sure. But that would mean that we can't do both, okay. That would mean saying you can't shade inside of an object. Okay. So what happens if I say, well, shading is now gone? No, wrong Raytracer. Right. So we stop this, and we say instead, right, this can go. We don't need this. We say shading, shading, shading. We don't apply shading. And we just return reflection results. What's obviously more info as we know now. Oh, and then we should kind of run that in release, but that's okay. This is completely black. Okay. So what I think is happening is that it's running into the recursion depth. I think this is going to happen all the time, right? Yeah. So this is happening like all the time. And then it's going to return 0 here because it can't. Dave, thank you for the follow, man. So this returns 0, right? Then it returns 0, 0, blah, blah, blah. It steps out. And then this is 0. Yeah. And then this is 0 as well. Oh, wait, we actually had cases where it was colored. I remember. You know, let's put this. We had this part, right? I actually wanted to put that breakpoint back and retest for that. And then we do need to disable shading again. But yeah, Dave, thank you for lurking around the stream and the follow. Hope you're enjoying the stream. Right, and then I wanted to put a breakpoint. Where would I put? I can't think. Right, put a breakpoint there. Right, so now there is no color that actually, or no no color that's actually, it's all black. There. So I think the only color we had before was from the shading. So it would make sense. That's actually very interesting. Because this code does seem to be correct to me. That's peculiar. So we're gonna have to fix this at some point, right? But I think for now, I can just leave this as is. And I think I'm gonna take a break from streaming because this stream has been going on for about, where's the time? Like 2.5 hours now. So refractions are one of the harder parts as well for the Raytracer. So I think I'm gonna call it here for today. Once I put back the code that I had, right? So this should be back, and then this should be no, sorry, it should be apply shading, and this should be reflect a reflection result. And I need to swap these, I think. So hid info and ray. Wait, didn't I have? I had a function here. Oh, it's just reflect. Okay. Oops. Yeah, there we go. And now we should have the Raytracer back to reflecting. There we go. We're rendering 10 cars now. Okay. And we're reflecting. Okay, that works perfectly. Then I want to thank you all very, very much for joining into today's stream. Harosh, if you're still here, or Hirosh, sorry, I suck at names. Thank you for the raid. It was good fun having you all around, and I will see you all some other day.